Hi. Okay, so yeah, my name is Kiana. Sorry. My dad is watching football right now. So this was a missed question on my test. Well, similar question. Okay, so first we're gonna multiply everything out. And then let's do x squared plus x plus 1. Multiply over here. So it's x to the third minus 2x squared plus x squared. Oh, hold on. Let me backtrack real quick. Let's combine this to make x squared plus 2x plus 1. Then multiply it by x minus 2. That'll be easier. So x to the third minus 2x squared plus 2x squared minus 4x plus x minus 2. So these cancel out. So you get x to the third minus 4x minus, 3x, sorry, minus 2. And then we're going to multiply all by 3, like we see here. So we get 3x cubed minus 3x minus 2. So that is our equation multiplied out. And then we're going to find the first derivative of it. And that's 9x squared minus 3. And we're going to find the second derivative since it's asking for a point of inflection, and it'll be 18x. We're going to set that equal to 0 because we're trying to find the x values, and it will come up as 0. So to find out what parts are concave up and concave down, we're going to go on the interval of negative infinity to 0 and from 0 to infinity in accordance to the second derivative. And we'll test negative 1 and positive 1. So if we put in negative 1 into the second derivative right here, then it'll be negative 18, and that's less than 0. So it'll be concave down. And then if we plug in 1 into here, it'll be a positive 18, which is more than 0, so it'll be concave up. So our answer would be x equals 0. Then from negative infinity to 0, it'll be concave down. And from 0 to positive infinity, it'll be concave up. Okay, so what I forgot to mention was that the first question was for number 2, and this is for number 3. Okay, so first what we're going to do is we're going to find the derivative. As you can see, I already kind of started. But we're going to find the derivative, and we're going to use chain rule for this. So the 2 is going to go out in front, times cos x, times the derivative of the inside, which is negative sine x, minus, and then we're going to keep the constant on the outside, 2. And then the derivative of sine x is cosine x. Then what we could do is we could take a negative 2 cos x out of this equation. So you're going to take a negative 2 cos x. You're going to end up with sine x plus 1. And then since it's multiplication, we could set this equal to 0. And we could separate it at this point. You'll get negative 2 cos x equals 0 and sine x plus 1 equals 0. Divide by negative 2 cos x equals 0. Yeah, so cosine x equals 0 at, that is a good question, pi over 2, and that's in our interval. And we're going to go one more just in case, 3 pi over 2. That's a little bit outside our interval, so we'll stop there because it doesn't really work. It doesn't go in our interval. We'll subtract 1 over here. So sine x equals -1 at 3 pi over 2, which isn't in our interval. So that's a no. So the only critical number we have is pi over 2. And in order to find the absolute max and mins, we're not gonna do the full chart, just this. So we have to include our interval endpoints, so 0 and pi over 2 and pi. So 0 into this equation. Let's do. Okay, so in order to find the absolute maximum, we're gonna find the y values. And since I'm a little lazy, we're gonna use a calculator. First, we gotta make sure we're in radians, which we are. So cos, oops, hold on. Cos, let's just do this, because I'm not sure this is how it's gonna work out. So cos of x times cos of x minus 2 sine x, and it came up with a random number because some random number was in for x. So we're gonna plug in 0 and store as x, and we're gonna click on this again. It'll give us 1. And then we're gonna put in pi, divide by 2, store x. Test this again. It'll be -2. And then our last endpoint, we're gonna plug in, store x. It'll give us 1. So, as you can see here, our absolute min is at 0, 1, and pi 1, because they're the same number. Oh, psych, absolute max. My bad. Then absolute min at pi over 2 and -2. And this is our answer. Okay, this is number 5 on the test that I missed. This is a similar question. Okay, so it says to find all values of c for the function f of x equals x cubed minus 2x squared plus 3x plus 1. Okay, so first we had to make sure that we could actually do the mean value theorem. So we have to figure out if it's continuous. And it is, because, yeah, there's no denominator. So usually it's continuous if there's no denominator. Differentiable. Yeah, we could find the derivative of that, so it's good. And then is on a closed interval. And it is right here on 1 to 3. Okay, so in order to find values to c, we have to find, we're going to use this equation. F of b minus f of a all over b minus a. So first we're going to find the derivative of the equation. It'll be 3x squared minus 4x plus 3. And then we are going to okay, and then from here we're gonna plug in this is A, this is B, so we're gonna plug in 3 into our function minus function of 1 minus 3 minus 1. So we're going to get 3x cubed minus 4x plus 3 equals, if we plug 3 into this, it'll be 27 minus 2 times 9 plus 9 plus 1. So 27 minus 18, that's 9 plus 9, that's 18 plus 1, that's 19. So 19, and then if we plug in 1, it'll be 1 minus 2 plus 3 plus 1. So 1 minus 2, that's negative 1 plus 3. That's 2 plus 1, that's 3. So 19 minus 3, that's 16. Divide by 2, that's 8. So we're going to set this equal to 8. We're going to subtract 8 from the side. So it'll be 3x cubed minus 4x minus 5 equals 0. And then what we're going to try and do is we're going to try and factor this. So I'm just going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this will simplify to 4 plus or minus 16 plus 60, right? Because negative 4 squared is 16 plus negative 4 times negative 5, that's 20, times 3, that's 60. All over 6. This will be 4 plus or minus 76 all over 6. Yeah, I mean, we could simplify this to 4 plus or minus, let me write it down here. 4 plus or minus 2, because we're going to take a 4 out. So 4 divided into 76, that'll be 19. 6. We could simplify this to 2 plus or minus square root of 19 all over 3. Yeah, so that will be our C value. Okay, this was number 6, or similar to number 6 on the problem. So it says f of 0 is 0, so that means we have a point at 0. And it says the limit of going towards negative 1. So we're going to put negative 1 right here is negative infinity. The limit of 2. So to the left of 2, it's negative infinity, but it also has to go through this point. So you can go like that. Then the limit of 2 to the right is infinity. So it's constantly going to go up. So we had a horizontal asymptote at y equals 0. And yeah, that's how you do that one.